number patterns. If you still remember, I told you that this section goes up to grade 12, right? So it's not a section that we are only going to learn in grade 10, but next year we will build more on it. And in grade 12, we'll build more on it as well, number patterns. And what is very important in number patterns is to understand the terminology, right? So if you can understand what the terminology means, and when you hear a certain word in a question, what does that mean? The moment you understand that, the better, and then the easier it is to work with number patterns. In grade 10, we are mainly looking at linear patterns, okay? We are mainly looking at linear patterns, which are known as arithmetic. So they are also known as arithmetic, right, sequences. That's what we are looking at basically. The number patterns that we concentrate on are linear patterns. So we want to look at different types of terminology quickly and then go into different kinds of examples. And the main focus today is to practice as many exam questions as we can, all right, because we are revising the section. So let's get into it. Okay, so first of all, like I said, let's talk in terms of terminology, right? Now, if you still remember, we talked about consecutive numbers. And we said that when we are dealing with consecutive numbers, we are talking about numbers that follow directly after one another. So for example, we can go 3, 4, 5 consecutive, or we can go 22, 23, 24 consecutive numbers, right? Sometimes also the examiner might not say consecutive numbers only, but the examiner will go consecutive even numbers. So if I can go consecutive even numbers, it means that if I'm dealing with even numbers, I can actually go right 2, right 4, then I can go 6. That's consecutive even numbers. If I want to write them with unknown letter variables, I can go x, then the next one will be x plus 2, then the next one will be x plus 4. I am dealing with consecutive even numbers, right? So you need to be able to understand when you hear the word consecutive. Don't just go quickly and say, oh, consecutive, I know it means one after the other, 3, 4, 5. Read again and understand. Are we talking about odd numbers? Are we talking about even numbers? Are we talking about perfect squares? So it's a lot. So please understand that. And in number patterns, we don't really use them as numbers. No, we use them as terms, right? So we use numbers. The numbers in the pattern are called terms. So when you are dealing with terms, for example, here, this will be term number 1, term number 2, and that will be term number 3. So we are dealing with terms, right? Then the other word that we see a lot in number patterns, it's constant difference. Because like I told you that we are dealing with what? Linear or arithmetic patterns in grade 10. So for you to see that it is a linear pattern, you will notice with what we call constant difference. So when you subtract the two terms together, then that means two terms that are consecutive, right? Please be very careful about that. The terms must be consecutive terms. So if they are consecutive terms and we subtract them, we get what we call the constant difference or the common difference. So by getting a common difference, I can automatically classify that pattern as linear, right? So that's what classifies the pattern as a linear pattern. So I cannot call a pattern linear if the constant difference, if there is no constant difference, meaning if I subtract the two terms that follow each other, and the answer is not constant throughout, hence I cannot call them linear pattern. Does that make sense? So for example, if I were to give you maybe 1 and give you 3 here, but then I give you 7, if I do that, 3 minus 1, that's a 2. 7 minus 3, that's a 4. The moment I've done that, automatically, it means that this is not linear. Why is it not linear? Because the constant difference is not the same. So the moment the difference is the same, then we call you linear. So in this section, we'll be dealing with those terms, right? Now, remember, I've already said that under number patterns, we don't call them numbers. When you are in a sequence or in a pattern, we call you terms, and we use T to denote term. So if I say T5, I mean the 5th term. That's what that means. If I say T20, I mean the 20th term. So whenever you see that, then it means that we are dealing with that particular term. So that's the language of number patterns. And then finally, we are going to talk about what is called the general term. And when you are dealing with the general term for linear patterns, you will notice that many teachers use different things. So you can use Tn equal to Dn plus C. Some teachers will call it Bn plus C. Some teachers will also use it as Tn equal to A plus N minus 1D, right? This formula, we'll use it mainly in grade 12, but some teachers prefer like introducing it in grade 10. So I think some of you might know this one and not know this one. This one can also be written as Bn plus C, any letters. But what is important is to understand that the letter before, right, N, this one here, it could be D, it could be B. This is the common difference, okay? This is the common difference. So when I ask you for the general term, I am saying find the last term in terms of N, right? So sometimes we might not call it a general term. We might just call it find the last term in terms of N. We mean find the general term. What does the general term do? So from the general term, if I were to substitute different values of N from 1, 2, 3, 4, 5, I will be able to create the pattern. So this is what is used to create the pattern. Okay, any questions so far? Great, any questions? Please ask me right on the chat if you are not sure of anything, right? I believe most of you have done it now, isn't it? You've done the section. I think last time when I taught you, most of you have not yet done the section, but by now you should have done the section, I believe. All right, okay. Now, so this is our terminology. So let's move on. Now that we understand the terms, right, now let's focus on the number patterns that we are dealing with, linear patterns. So like I said, if your teacher used this formula, I'll write it here as well. Maybe your teacher used A plus N minus 1D. How many of you, their teachers use this one that I'm writing now? Thumbs up or hands up if you have used this one. If you have used this one, anyone? Natalia, okay, Dimple, all right, good. Okay, that's fine. Okay, I can see some of you have used this one. So if you have used this one, A represents your first term. So this is first term, all right? Now, and then D is exactly like in the other formula, which is your constant difference, right? So the only difference is that we also introduce the first term of the sequence, and then N, we know what is that? It is the number of the term, which is exactly the same as the other formula. So number of the term. So just in case you use this one, right, you can still continue to use it. It's okay, right? Now, going back to our normal grade 10 formula, which is Tn equal to Dn plus C. So what is the first step that I take? Number one, I will need to find the common difference, meaning that I need to subtract so that I see the common difference. The moment I see it's a common difference, then I can conclude that it is a linear pattern. So the moment I can conclude it's a linear pattern, then it means I can use this formula. Now, to find your C, you need to take your first term and you subtract your D. So in a way, you are going backwards, and then you substitute it into the formula, your D and your C, and you have found your general term. Right. So this is very important that we understand how to find our general terms. Okay. Right. So we're going to use them just now, okay, to find the general term. Now let's look at a pattern and use it. So the question says sequence 3, 8, 13. Right. 3, 8, 13. This is our sequence. Then the question says find the next 3 terms. Right. The moment that the question says that, first of all, find out what is happening in the sequence. So I always prefer to use these arrows here. So what this means is that this is T1, this is term 2, and this is T3. That's the only things that we were given, right? So we can find T2 minus T1. That will be 8 minus 3, and that will give me what? 5. Then we can also go T3 minus T2. 13 minus 8, and it is giving us 5. So we can see already here that T2 minus T1 is equal to T3 minus T2, right? That automatically means that we have found our D, which is equal to 5. Because there's a constant, then it is therefore a linear what? A linear pattern, right? Okay, so I need to make sure that I understand that before I answer my next question. Now it is my linear pattern. So which means for me to get the next 3 terms, I need T4, I need T5, and I need T6. Who can give me T4, T5, T6? Right, let's go, guys. Remember, we are putting 5, 5, 5. Thank you, Natalia. Says the first one is 18. Right, let's go, guys. Then we add a 5 again. What do we have? Right, thank you, Emma. 23. Thank you, Dimple. Thank you, Natalia. And then the final one. Thank you, guys. 28. Thank you, Jaden. Right, so what are we doing? Thank you, Mohadi. Right, so what we are doing is that we are just adding. We are adding your constant difference to find your next 3 terms. Now, we have found the first one. Now, it says find the general term. When I hear the word general term, automatically that means the examiner wants me to find Tn. So it is Tn equal to Dn plus C. Right, let's know, right? If we found our D, yes. So we know who D is. Now I want to show you how to find your C. So to get your C, you come to your T1 here and you go backwards 5 times. So you are saying we want to subtract from 3, we'll subtract 5 to get this number here. What is that number there? The C. So this will give me C. So 3 minus 5. Thank you, Faith. Thank you, Emma. It will give me -2. So I have found my number. So then I can come in here now and say Tn is equal to D, which is 5n, and C is equal to 5n minus 2. That's my general term. Now this general term, if I were to substitute to check if it is correct, I'll go where n is, I'll put 1. Can you see? 5 minus 2, can you see? My answer is a 3. If I find T2, again, 5 times 2, right, minus 2, 10 minus 2, my answer is an 8. So can you see, from the general term, I am creating the sequence back, which means my general term is correct. Okay, so I'll use that. For those people that their teacher used A plus N minus 1D, right, so that we help them as well. It means that A here, they need their first term, which is that. So they will substitute A, 3 plus N minus 1, and then they substitute the 5 that they found there, and then they will distribute the 5 into the bracket, 5n, distribute it into the bracket minus 5. Then they will end up also with 5n, 3 minus 5, -2. So can you see that both of you will find the same answer? All right. So it does not matter which method you use, you will also get the same answer. Right. Now the next question says, now find the value of the 45 term. So which means wherever we see n, we want to replace that point with what? 45. So we are going to go T45. Who is giving me this one? 5 times 45 minus 2. Right, let's hear it. We are putting T45, right? So wherever we see n, we replace that with 45. Using your calculators, guys, go, go, go. 223. Thank you, Jaden. Thank you, Timbo. Thank you, Faith. 223. Right, we have found our answer. Then the last term says, which term has the value of 403? So I am taking the whole Tn, and now I want to find n. So which means wherever Tn is, I'm replacing with 403 equal to 5n minus 2. So what am I doing here? I am solving a linear equation. So let's take this across. This will give us 405 equal to 5n, right, divided by 5. Can somebody give me 405 divided by 5? What is n? Right, thank you, Kumo. Thank you, Natalia. Jaden, 81. So what does this mean? It means, therefore, thank you, Sona, T81 is equal to 4. Any questions so far, guys? Are we good? Right, thumbs up if you can understand what we are talking about. Right, thank you. All right, communicate with me, okay? If you are not sure of anything, please talk to me, right? Okay, right, now, let's move on to our next question. Right, Mpho is told that a sequence is nth term of 15n minus 2. Can you see how this question is asked? Let's talk about this question. Right, they say the sequence has nth term of 15 minus 2. What does this statement tell you? What are they talking about? Who is that nth term? It is also known as what? This nth term is also known as the general term. Thank you, Natalia. So in a way, the examiner has given you the general term here. So they are saying the general term Tn is equal to 15n minus 2, according to this question. So what am I doing? As I am reading my question, I want to understand what is it about. And then I will now look at it and answer, all right? So understand, highlight important stuff as you, in maths, it's very important to use color. Highlight with different colors. It helps you to think a little bit better when you are in your exams, okay? Now, she has to find which term is equal to 96. She is stuck because she keeps getting an unexpected answer. Perform the calculations and then explain the answer. Right, so what are we being asked here? She is wanting to find which term will be equal to 96. So what is she looking for? She's looking for n. Thank you, Faith. Thank you, Emma. So she needs to solve for m equal to 96, which means on where Tn is, we must put 96 there, isn't it? And then we will go 15n minus 2. Right. So that's what she needs to do. So we are going to perform our calculation. Tn is 96, so we equate it, and then we find that. Now we are finding that 6, it's not really a whole number. That's why she was stuck, isn't it? So which means that when she performed the calculation, she realized that there was a decimal, but we are looking for a term, and a term cannot be a decimal. So what does that mean? It automatically means that this particular number does not really, it's not part of the sequence. Agreed? Because your sequence must be natural numbers, must be whole numbers. The terms must be whole numbers. So if you get a term that is a comma, automatically that means that that particular number does not belong to this pattern. That's why she kept on getting an unexpected answer. All right. Okay. Right. Another example. Right. Now, sometimes we are given things. Right. Okay. Yes, Faith. Faith says, what if the linear pattern is fraction? Still, even if the linear pattern is a fraction, it is the pattern that is the fraction, right? In this case, she was looking for n, not the term. So the term can be a decimal, no problem. The T2 can be a 5,5 or a 2/3, but n cannot be a 2/3. N has to be a natural number all the time, Faith. I'm answering Faith's question. Okay, right. Now, what we are given here is a what? This is 2 terms. But then the thing is, the examiner did not give us the first term either. So these numbers are not consecutive. What does this mean? It means that when n is equal to 6, the term is actually 8. And here it means that when n is equal to 9, the term is actually what? -1. And then they are saying, now find T5 and T7. For us to find T5 and T7, what do we need to do first? We know our general term is Dn plus C, agreed, right? So with Dn plus C, we know, in this case, we know n and we know the term. So can we create simultaneous equations? So the moment you see this, you create simultaneous equations. So you are going to create your first equation, substitute in here. Wherever you see n, replace with 6, T6 is an 8. Then we are going to go 6D plus C. We will call this equation number 1. We will do the same with 9. Wherever we see Tn, we replace with T9, which is -1. And where we see n, we replace with 9. So 9D plus C. And then we'll call this equation number 2. In grade 10, you have done elimination method. Do you remember it? In simultaneous equations. So you can use that now to eliminate one letter here. And the easier one to eliminate is C. So if I subtract equation 1 minus equation number 2, I can go 8 minus -1, that will give me 9, equal to 6 minus 9, that will give me -3D, C minus C, 0. If I divide here and divide here, D is equal to -3. Then I can take this and sub it in either equation 1 or equation 2 to find C. So I'm going to go into equation 1 and I'm going to say 8. So equation 1 is 8. So if I sub it in 1, it will be 8 is equal to, wherever I see D now, it's a -3 plus C. So that I solve for C. That will be -18 plus C. So 18 plus 18, that's 26 is equal to C. So what is my general term? Tn minus 3n plus 26. I cannot find T7 and T5 without the general term. Now that I've got it, I can now go, so T5, wherever n is, we put a 5 plus 26, right? Can you give me this one? T5, who is 3 minus 3 times 5 plus 26? Somebody give me the answer. Right, this question can come as different things. We can bring you as a diagram. Thank you, guys. So we are getting our answer as 11. Right, thank you, Kumo. Thank you, Dimbo, Natalia, Faith. Right, we also do the same with T7. T7, meaning wherever n is, we replace with 7. Can you give me that one too? Wherever s, we replace with 7, which means T7 will be equal to, right. Thank you, Timbo. 5. Thank you, Natalia. Right. Do we understand what I've done? These are called, so the method that I used here is called elimination method. If you don't want to use it, you can use substitution method. Right. We are refreshing our memories, right? Okay. So remember, you create your sequences. Right. So in here, they've used, right, substitution method. Can you see it? So we have used substitution method. So meaning T7 was equal to T6 plus 8D, right? And then you found T8 as T7 plus D. So basically, if T7 is 8 plus D, you can substitute it in there, and then they found D as -3. So they've used a different method from the one that I've used, but the answers are exactly the same. So you can use any method basically for you to be able to solve it. The reason why I use that method is simply because sometimes the examiner might not give you numbers that are consecutive. I could have asked for T50 here, then you wouldn't be able to use this method that is here, but the one that I used, where you do elimination and then find the general term and find T50. All right. So you need to be familiar with the different types of what? So we have safe, 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 and it continues safe, safe, safe until we reach the 263 later. So the 263 already you can see it's not an even number. So what does that tell you? All right, the first safe is term 1. All right, okay, and then after that, what we do? All right, with 4 things. And then the second one will be how many things? All right, okay, Natalia is coming up with something. She's saying T1 will be 4. First one, say T2 will now be safe plus safe, which is 4 plus 4, 8. So are we saying T3 is now safe plus safe, which is equal to, right, okay, 8. So T3 will be now 12. Are we saying that? Right? And then T4 will be now 16. So these are the things that we have. All right. Okay. So what do we do next? We have got the sequence, but we want the 263 later. So what does that mean? Okay, your constant difference, right? So Natalia says constant difference, and the constant difference is 4. So Emma says, now let's find the general formula. So it will be 4n, right? We go backwards, 0. So Tn is 4n, right? So what do we do? We have found the general formula. So what do we say now in the general formula? Now that we have the general term, what do we do next? Right, okay. So we are saying we want the 263. So in place of Tn, we put 263, all right? 263 equal to 4n, all right? 65.75. So then what does that mean? Considering that the numbers that we have here are multiples of 4, and we are getting 65.76. So which means that the 26 third later is what? Right, how did you see that it's F? Okay, I can see answer saying it's F. We were supposed to reach here, but we are here. So the next round of number was going to be a 66, isn't it? T66. So T66, meaning 66 was going to be E. That was going to be the last one, isn't it? To have a complete one. So since we didn't reach T66, but we ended somewhere along the way, so that means that we are dealing with F, right? So what are we doing? Again, in this case, we are just dealing with the same letters, okay? So 65, if you didn't want to write it as 0.75, you would have said the remainder was a 3, meaning the third letter. So 65, we are full on E. Then we started SAF. All right. Thank you guys for taking part into this one. Right. Perfect. I can see you now understand what we are dealing with. So can you see that sometimes your questions don't really come like this, but they can come in any other way. So we have to be very, very careful when we are dealing with our number patterns. Okay. All right. So I'm going to do the last question here, and then we will go into OneNote and try past exam questions now. Right. Although these ones we are doing are also past exam questions. A shop owner wishes to display cans of food in a triangular shape as shown in the figure below. There is 1 can on the top row, first 4 tens. Thank you, 1, 3, 5, 7. Right, so we are dealing with 1, 3, 5, 7. Thank you, Natalia. Now, in what type of sequence are the teens arranged? What type of a sequence is this? So remember what I said? Thank you, Natalia. The only way for you to mention what type of a sequence is to check, do I have a constant difference here? Right? So looking at this, do we have a constant difference? Yes. What is it? 2. So what type of a sequence? It's a linear pattern or a linear sequence. Thank you, Timbo. So you need to check, okay, So don't just rush. You need to check what is happening between T2 and T1 and T3 and T2. The moment you see a constant difference, perfect, you can call it linear. Now it says, write down a formula for the term of the sequence. So what are we looking for now? For question 3, what are we looking for? We are now looking for question 3, we are now looking for general term. Thank you, Natalia. Right, we are now looking for the general term. So we're gonna go Tn dn plus c. We have found our constant difference. Let's go backwards. What will be c? C will be equal to, right, 1 minus 2. What will that give us? C is equal to -1. So the general term will be dn, that is 2n minus 1. Right. How many cans are needed for the 15th row? What are we looking for here when we say that? How many cans are needed for the 15th row? What are we looking for? Right, Tn, good. So we want T15. So we are going to go wherever n is, we replace with 15, right, minus 1. So 30 minus 1, that will give me 29. Thank you, Faith and Emma. In which row would there be 27 cans? What are we looking for now? What do we need now? Right, now we need n. Thank you, Emma. Thank you, Timbo. So wherever Tn is, we are replacing with 27 equal to 2n minus 1, right? You need to solve this. That will give you 28 equal to 2n divided by 2, meaning n is equal to 14. So T14 is 27. That's what it means. Right. Can I hear questions? So this is what we call patterns. So what we want to do next is to go over some past questions, past exam questions together, right? Any questions so far from what we have done? Any questions, guys? Okay, if you're unsure and if you are rushing, please let us know, okay? Right, so I'm gonna share my OneNote now, right? Yes, Natalia, you can use the other formula, definitely. You don't have to use this one. You can use the other formula, the Tna plus n minus 1d. Depending with what your teacher taught you, you can use that too. Perfect, all right? Okay, all right, now let's try some questions together, right? So first question that we are given here says, given the linear pattern, 8, 3 minus 2, right? 8, 3 minus 2. Write down the next two terms of the pattern. So what is the first thing that I need to do? I've got my 8, 3 minus 2. I'll write it here. What do I need to check? Right, I need to check what type of the pattern is this by looking at the constant difference. Thank you, Faith. Thank you, Natalia. So let's go. T2 minus T1, 3 minus 8, -5. Right, thank you. Minus 2 minus 3, -5. So I can see, okay, there is my D. So if I found my D, can I now find the next two terms? Right, can I hear the next two terms now? Let's join this thing. Right, we want the next two terms. Right, so if I add 5 here, what is the next term? Right, -7. Thank you. Right, the next term. Right, minus, is it minus 18 or 12? Minus 7, then 12. Isn't it -12? Right, thank you, guys. Okay, so that is our next two terms. Then the person goes on and say, now find the nth term of the pattern. What are we looking for when we hear that? Find the nth term of the pattern. We want to find the general term. Yes. Now we have already noticed that D is equal to -5. So we are going to go and find C. Can somebody give me C here? Who will be C? Here. So we write that Tn equal to Dn plus C, right? D is -5n, right? And we can see D 18. All right, thank you, guys. And C is equal to 18. There we go. We have found our general term. So can you see that your questions are not different from what you normally know? It is more or less the same kind of questions that we've been talking about already. Right. Then it goes on to say, now calculate T30. Right? So what are we doing? Into the formula, we are substituting, right? So let's go into the formula. Wherever we see n, we replace with what? 30, right? T30 minus 5 times 30, right? Plus 18, right? Give me an answer. Minus 5 plus 30. Thank you, Emma. Minus 137. So meaning if we had gone on and say, after the T5 here, go T60, 70, 89, until we reach T30, put in the -5, we were going to end up with a term minus 137. That's what it means. Now, which term of the pattern is equal to -492? Which term is equal to -492? What are we looking for? We are trying to find n. Thank you, Faith. Thank you, Timbo. Thank you, Emma. So we are going to the general formula where Tn is, we replace with -492 equal to -5n plus 18. Right, let's bring the other number across. -492 minus 18, right? -5n. Right, I can see your answer already. Kumo says the answer is 101, right? Divided by -5. So n is equal to 101. So it means that T101 is basically equal to what? So that's what it means. Therefore, T101 is equal to -492. Right. Any questions from what we have done so far? Right, guys, remember that your questions don't really change. Okay, they are the same. It's all about understanding what the examiner is talking about. Right now, question B. Question B says the first four patterns, right? The first four terms of pattern A and pattern B are shown. So we have two patterns here. Find the general formula for the nth term of pattern A. Right, let's look at pattern A. I'm going to write pattern A here so that we see it. So what is pattern A talking about? Looking at it, what do you see? What type of a pattern is this? 1, 3, 5, 7. That's pattern A, right? 1, 3, 5, 7. Right, what type of a pattern do you think this is? So we have 1. Thank you, Emma. Thank you, guys. Thank you, Natalia. They think that it is linear. Why are they thinking like that? Because 3 minus 1 will give us a 2. 5 minus 3, a 2. 7 minus that is a linear. So the question says, find the general term. So let's go. So if it is a linear and we have found that this is n, who is our C? Let's go. C will be equal to, give me C. C will be equal to, we go backwards, remember, 1 minus 2, negative 1. Thank you. So therefore, Tn is equal to 2n minus 1. Thank you, Faith. Thank you, Brandy. Thank you, Kumo. Right. Now we have got for pattern A. Remember, this is for pattern A. Then the person says, now, hence or otherwise. When I hear the word hence, it means that you need to use some of the things that you've found about. Can you find the general formula for the nth term of pattern B? Right. Let's look at how pattern B is looking. Pattern B says 1, then it goes 9, then it goes 25, then it goes 49. If we were to compare this and that, what is the relationship? Right. You can see that pattern A is the square root of pattern B. Or we can say what? Pattern B is squared of pattern A. So what is the general formula then for this one? So Tn will be equal to, for pattern A. If we are taking, for pattern B, if we are taking pattern A and we are squaring it. So can you see, if I take this and I square it, 1 squared, 1, 3 squared, 9, 5 squared, 25, 7 squared, 49. So what is my Tn? If pattern A was 2n minus 1, how would I produce the second pattern? By saying, right, Tn and raise it to the power 2, not just the n only, the whole thing. So you put a bracket on the whole formula and then you square it like that. Okay, right? Does that make sense, guys? So you're taking the whole thing and you're squaring it, which will give us 2n minus 1 squared. Right, let's expand this. Later, you know how to do products, right? And somebody help me with that. When it's a binomial like that, what does it look like? When it's a binomial like that, how do we expand it? First n squared, so 2n squared, isn't it? Minus 2 times, right? 2n times what? Times the 1, isn't it? Right, what else? Right, and then we square the last term, agreed? Right, and then we square the last term plus 1 squared there. So what is our general formula? It will be 4n squared minus 4n plus 1. Right, I see a hand up. Right, let me get the question. Okay, well, I'm a bit confused. All right, we are saying here, right, and I explain this. We put clean page there. Right, so what we are talking about here is that we have got pattern A, right, and our pattern A is 1, 3, 5, 7. This is pattern A. But pattern B becomes 1, 9, 25, 49. Right, now what we have noticed was the general formula for pattern A, Tn, was equal to 2n minus 1. So for us to create pattern A, we need 2n minus 1. But what we noticed was to create pattern B, all they did was they took pattern A and squared it. So 1 squared, 3 squared, 5 squared, 7 squared. If you do that, you will find this is 1, 9, 25, 49. Meaning they took pattern A and they squared it. So to find the general formula for this one, I just need to take the Tn for A and I need to what? To square it. That's why the same hence. So the Tn for A, if I can square it, it will bring me Tn for B. That's why I did that 2n minus 1 and I squared it. Now all I am doing is to expand the bracket. So I thought you guys know how to do the binomial. So since you don't know how to do the binomial, you can do for you. Right, then you go 2 times 2, 4n squared. And you see, minus 2n, right? Minus 2n. Right, so you can do your for your method, and then 1 times 1, that is plus 1 there. And then you find that the general term for pattern B is 4n squared minus 4n plus 1. If you don't want to expand it, then you can leave it as what? 2n minus 1 squared. Agreed? Is that better? Is that better? Good. Okay. Right. So that's what we did. All right. All right, guys. Then there's another hence again. The moment you see hence, it means the things that you've used above, you can use them again here. Let's go. Find the general term for the pattern 0 minus 6 minus 20 minus 42. Simplify your answer as far as possible. Right. Let's look at this pattern. Do we see anything important or similar to what we know above with the pattern A and pattern B? Do we see anything? This is 0 minus 6 minus 20 minus 42. What do we see? Do we have anything that we can say from these two here? Because the moment they say hence, it means I can use something above here to get my answer. Right? Look at the table. Pattern A, pattern B. Is there something they used in pattern A, pattern B to create 0 minus 6 minus 20 minus 40? Can you see it? I can see it. Can you see it? If you take pattern A, yes, thank you, Josh. Pattern A minus pattern B. So pattern A minus pattern B gives you this new pattern, right? Thank you, Josh. So let's go. 1 minus 1, 0. Can you see? 3 minus 9, negative 6. 5 minus 25, minus 20. 7 minus 49, minus 42. That's why they say hence. So what does that mean? For me to find the general term for this pattern, it will be equal to pattern A minus pattern B. Now, what is the general term for pattern A and what is the general term for pattern B? We have just found them above, isn't it? So let's put them in. General term for pattern A, we found it to be 2n minus 1. Then the general term for pattern B, we found it to be 2n minus 1 squared. But remember, we went on to expand it and we got it as what? 4n squared minus 4n plus 1. So I'm going to put it in. So this pattern will be 2n minus 1 minus 4n squared minus 4n plus 1. Right. Then the examiner said, simplify your answer as far as possible. So let's simplify our answer. So what are we doing? Right. We remove that bracket. Remember, when you have a minus, you introduce it inside to everybody. Minus minus plus 4n minus minus negative 1. After this, we need to group our like terms. We can see 2n and 4n. So if we add those two, what would that give me? That would be 2 plus 4, 6n. Then we also see 4n squared by itself, right? So we write it as it is, right? So that would be minus
4n squared. Then I can also see the numbers minus 1, right? What is minus 1, and that will give me negative 2. So you can rearrange this now. Start with 4n squared minus 4n squared plus 6n minus 2. This is the general formula. How do we know that we have got it correct? We can check, right? Let's substitute t1. So wherever n is, let's put 1. What do we get? 4, 1 squared. Can somebody give me this? 6, 1. Put in your calculator. What is the answer? If you put this in your calculator, what is our answer? Please put the brackets the way I put them. Put the brackets the way I put them. Minus 4 bracket 1 squared plus 6 bracket 1 minus 2. What are we getting? Thank you, Emma. 0. Try T2, right? Thank you, Mohari. Try T2, right? Put a 2, right? Thank you, Sona. Right? Put a 2. What are we getting? If we put a 2 there, what are we getting? Right, negative 6. So do you see that this is correct? So if you have to continue, you get also minus 20, minus 42. Right now, on this question, it's tricky, guys, right? Very tricky. If you don't understand the way. But the examiner gave us hints, a lot of hints. What was that they gave us? It was the hence. You see, whenever the examiner says hence, it means that you need to use your answer above to create this answer. It is telling you that what you need to do here, it has something to do with what is above. That's what the hence is telling you to do. So in this case, if a person did not understand what hence is all about, then they were not going to get all this correctly. So you need to have a sharp eye to check what type of patterns are we creating here, and what do I have in terms of pattern A and pattern B? What is the connection? All right, questions on this one. Questions. So do you see? Do not take what is this? Do not take function patterns for granted. I know some people think that it's an intersection, I can rush through it. Sometimes it doesn't come that way. So patterns can also be very nasty. Okay, so don't take them for granted. Make sure that you understand the question, understand the terminology that they're talking about, the relationships that are happening, and then you'll be able to answer properly. Right? Anyone that didn't understand what we did here? Okay. All right. Let's take a break. Then I'll come and do a full question. All right. And let's look at more questions. Right, and then we are going to complete the session, right? So the next question, so like I said before, guys, remember what I said, that now patterns is not as easy as sometimes people put. So don't take it for granted. Practice, practice, practice. Okay, so this one we are told dark house D and light house L are used to create patterns on a floor. So they're doing a kitchen floor maybe, right? And we are told that the first 4 patterns are shown below, right? For the patterns that follow, the tiles are arranged in a similar manner, right? So we see pattern 1. So let's try and have things here for the dark and the white ones. Let's create a pattern. Let's start with the dark ones. So dark house, right? Let's have the pattern. What does the pattern look like? Somebody give it to me. Dark, 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 dark ones. Right? We're starting with 1, yes, followed by 3. Take a faith. Let's go. Right. We have a 5, right? And we have a 7, isn't it? Right. Okay. 1, 3, 5, 7. Perfect. Right. Let's do lights so that we have got all of them before we start answering. Lights. Right. Let's go. The light ones. What do we have first? 0, yes. Then we go 1, yes. Then we go 4, right? Then the last one is how many? 9. Okay, right. So we have seen our patterns. Okay, so we have dark and we have light. First question says, how many dark tiles were used in pattern 5? So let's go to pattern 5, right? Pattern 5. So if we're going to go to pattern 5, let's go into our dark tiles and see. We have 1, 3, 5, 7. What do we see? 3 minus 1, 2. 5 minus 3, 2. 7 minus 5, 2. So obviously pattern number 5, we are adding a 2. That would be a 9. Thank you guys. I can see your answers. Thank you. Right. Okay, so we will write 9 there. Now, how many light tiles were used in pattern 6? Right. Now let's go to pattern 6. Pattern 6 a little bit different. If we look at it, is it linear? Is pattern 6 linear? No. Right. But there's something that we are noticing. We are noticing that 1 squared is 1. 2 squared is 4. 9 squared is what? 3, right? I mean, 3 squared is 9. So which means in pattern number 5, what will you end up with? What is pattern 5? 16. So what is pattern 6? That's the one they want. 25. Thank you, Zara. Thank you, Timbo. Thank you, Sonas. Right. So you can see we are squaring the 0, 1, 2, 3, 4, 5. Isn't it? Right. So, okay, Faith says 9 is 10, 4. Yes. 9 is 10, 4. And 10, 5 is 16. But the examiner wanted pattern 6. I'm now doing B. Now, but this 9 was for A, Faith. This 9 was for A. For pattern 5. Pattern number 5 for the dark ones, for the first one. So now on this one, our answer will be 25. Okay. Now C says, write down the general thing for the dark ones. Let's go. C, dark. We have seen that the constant difference is the 2. So let's go. What is C? What is C? C will be -1, right? Thank you, Emma. So which means that we are dealing with what? T, D, the dark tiles, the N will be equal to 2N minus 1, right? Okay. So we found our general term. Now it says now, what about the light tiles? The general term for the light tiles. What do you think will happen to the light tiles? The T lights. Considering they are not linear, right? But we have noticed that if we look at the patterns, right? We have got 1 squared, right? We have 3 squared there. We have 5 squared there. So can you see what is happening in terms of, let's use pattern D, guys. Let's go to pattern D. What are we seeing in pattern D? D, the first term is a 1. If we square it, it gives us the second term of the lighthouse. Then its third term squared. If we square it, it gives us the fourth term of the lighthouse. Then its next term 5 squared. If we square it, it gives us the sixth term of the lighthouse. Right? I see Faith as an answer. Faith says it's n minus 1 squared. How did you get there, Faith? Right. Natalia says for the dark house, you could demonstrate using other formula. Oh, okay, could you demonstrate using the other formula? Right, so for the dark house, if you were to use the one that you know, Natalia, right, it would be Tn equal to A plus N minus 1D, which is exactly the same here. And your A in this case is a 1 plus your D is a 2, bracket N minus 1. So if we expand that, Natalia, you will notice that you end up with 1 plus 2N minus 2, which is exactly equal to 2N minus 1. Right? That is the dark. Okay, now we are dealing with the light one. I want Faith to explain how she got a N minus 1 squared. Right. Faith says take the same number, then subtract the 1, then square it. Right. So to get a 0, right? Okay, I get you. So to get the first one, you went 1 minus 1, then you squared. Same number, then subtract 1 to it. All right. So using D, right? So she went using D. She realized that if I take the number, right? T1. So for the first term for the light one, she went 1, right? Minus 1, then she squared it, right? Then for T2, the same number, right? Then she went 2 minus the number there, 3, then she squared it. Is that what you did, Faith? Then she went on, right? Oh, subtract 1, my bad, subtract 1. Subtract 1, 1, okay? Then went on 3 minus 1 squared. So you're using the term only, right? So you ended up with, okay, now I get it. So which means that if you are using the term, which is n, right? So if my term is n and I subtract 1 from n and I square it, I'll end up with the general formula. All right, thank you. Right, perfect. Okay, so this is our general formula. You can test it by substituting. So when n is 1, 1 minus 1, when n is 2. So here, the examiner did not write hence because they wanted you to be creative a little bit and look at your answers and see how you can create the second pattern as well. All right. Okay, now which pattern will have exactly 64 light floor tiles? So we are using which general form to get that? 64, the one we have just created, right? So if we are dealing with 64, what are we talking about? We take the light one, right? The Tn of the light one, n minus 1 squared, and we equate 64 to it, right? How do we solve this? Expand your bracket, okay? Using your binomial, you remember your binomial, right? Bring 64 this side, equal to 0, right? Then we end up with n squared minus 2n minus 63. Can I have factors of 63? That will give me a 2. We want to factorize now. Okay, let's go. Guys, wait, factorize for me. Factors of 63. Factors of 63. If they have a casual calculator, do you know how to use it? How many of you know how to use the silver one to find the factors? To find the factors for this, how many of you know how to use it? The silver calculator. Okay, let's see one person. So most of you don't know how to use it. You can, if you have the silver calculator, you can actually use it, or the new white one. You can put this under mode, right? Mode equation. You can use this also in your factorization, right? Mode equation. Then you choose option 3. Option 3, then where A is, you replace with 1. You can try it now if you've got that calculator. B minus 2, C minus 63. It will give you the two factors, right? So the factors are 9 and 7, right? Let's figure it out now. Minus 9 plus 7, which means n is equal to 9, or n is equal to minus 7. So obviously, we reject this one because it cannot be a negative, remember. So what is our final answer? Therefore, it is the 9th term. The 9th term will give us 64 white tiles. Are we okay? Are we okay? For those that have used their calculators, did you get that answer too? Right, so you can use your silver calculator to help you with factorization and solving your equations. Okay, right. So it will give you the two things, and then you recreate the brackets. So if it gives you as a 9, then it means inside the bracket it's a negative. If it gives you as a positive, then it means inside of that bracket it's a negative. Yes, I see your hand up. Right? Yes.
Ma'am, I wanted to,
yes.
ma'am, I wanted to ask, couldn't you just square root 64 and then add 1?
Yes, you can. We can do that method too. Or you could have gone n minus 1 squared. I was going to show you just now as well. 64, right? And you could have, right? The problem with this one would be some people will forget. So to say that whenever you do a square root, what do you do? Plus minus. If you don't do that, then you'll be wrong. Okay, Emma. You have to put the plus minus. You have to get the two answers and reject the other one. So then after that, you can carry the 1 across, make it positive. Plus minus 8. Then you're going to say therefore 1 plus 8, 9, or 1 minus 8, negative 7. And then you reject that one. Then you say therefore T9 is equal to 64. Right? Does that make sense? So you can use that. But guys, the most important thing is that I want you to understand that most of the time when you're solving the equation, you need 0 on the other side. Hence, I'll recommend that more than using that. Only use that if you understand it better. Okay. Right? Thank you, Emma. Right, then it says each ductile is 0.3 meters wide and 0.6 meters long. Calculate the total area covered by all the ductile in the first 100 terms. Right. So how many ductiles do we get? We need to find that first. 100 terms. What is our general formula for ductiles? Tn is equal to 2n minus 1. So if we have got 100, first 100 patterns, how many tiles are these? Total area covered by all the ductile in the first 100 patterns. First 100 patterns. So remember, we are dealing with 1 plus, we have 1, 3, 5, and it goes on, and our general term was what? 2n, right? Now we have to be careful, which is the 100 pattern is what T100 will be how many? 200 minus 1, which is equal to what? 199. Okay, but what does this mean is that we have T1 to T100, and T100 is 199, guys. T1 is what? It's 1. So we need to add all of them until the end. How do we do that? We need a total area covered by all the ductiles from the beginning to the end. So it's not the 199 here. It means in T100 there are 199 ductiles. Now I need to add the T2. So we need to add them. The T3, we are adding plus, dot, 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 plus. So we need to add everybody until we reach 199. So we need that total. How will we find that total? So we are adding 1 for the first term, plus 3, plus 5, plus 7, plus 9, plus 11. All the odd numbers until 199. We want the sum of all the odd numbers until 199. What is that sum? So there is a method, which I cannot really show you because you're in grade 9, you're in grade 10. It's a grade 12 method, the sum. But you could actually add all these by looking at it, what do you think you end up with? The sum of these terms. There are 100 terms, isn't it? 100 of them. So this is the method that we use in grade 12. Okay, where A is your first term and L is your last term to add the sum. So this will be 100 over 2, right? Then that will be 1 plus 199. What would that give us? 200 times 50. What is 200 times 50? 200 times 50, guys. 10,000. Right, thank you, 10,000. So there are 10,000 of them. So you have to be very careful on this one. So you cannot use the 199. The 199 is to find the last one, which means the examiner was expecting you to add them one by one until you reach 10,000, because this formula is only introduced in grade 12. Okay, the sum. But that's what you needed to use here, sum. So you guys are going to add all of them like individually. There's no like a formula that we're going to use except to say 5 plus 3 plus 5 plus 7 until you reach 199, and you're going to get 1,000. But this is a shorter way to do it, right? And then after that, you can now calculate the area, right? So the tau is a rectangle. What is the area of a rectangle? Area of a rectangle is equal to what? Area of a rectangle. How do we find area of a rectangle, guys? Let's go length times breadth. Good. So, which means the area of 10,000 times length is 0.6 here, and the breadth is 0.3. Can somebody give me that answer? So the area will be 10,000 times the area of one tau. There are 10,000 taus. Give me the answer. What do we get? 10,000 times 0.6 times 0.3. Right, 18,000. Okay, right. So what are these? Is it 18,000 or 1,800? There are two answers. 18,000 or 1,800? 1,800. Okay, square meters. Okay, all right. So this one, I would say it is that question that we call a level 4 question, where it's not as easy as it looks like. Okay, so I know that most of you were going to get that part of getting the 100, but most of you were going to be tempted to say 199 times the area of the square, which was incorrect because they wanted the total number of all the dark taus in the first 100 patterns. So we needed to start from T1 until T100 and add everybody, okay, to get the answer. Right. Okay, question number 3. Right, question 3 says, okay, I'm gonna wrap this so that we can space. Question 3 says, consider the sequence 5, 8, 11, B, 17. Find the value of B. Can we check? Is it linear? Right, let's quickly check. Is it linear? 3. Is it linear? Are we linear? 5, 8, 11, B, 17. Are we linear? Right, thank you. Yes, why? 8 minus 5 is 3, isn't it? 11 minus 8 is what? 3 as well. So who is B? If we were to add a 3 there, B was going to be equal to 14. Right, thank you guys. Right, now find the Tn of the sequence. Let's go. What will be Tn? So 3n, right? Let's find C. Go backwards, 3. What will we have? 5 minus 3, C will be equal to 2. So 3n plus 2, right? We found our Tn. Right, then it says, calculate the value of the 15th term. T15. So wherever n is, we are putting 15, right? Plus 2. What is our answer? Right, 45 plus 2, 47. Right, thank you guys. Right, then it says which term of the sequence is equal to 83. So we are now equating 83 is equal to 3n plus 2. Right, we take 2 across. 83 minus 1 is equal to 3n. So 81 divided by 3 equal to n. Right, thank you guys. Thank you, Faith. Thank you, Jimbo. N is equal to 27. Right, okay. Now, we've got part B now. Part B says, consider the pattern below created by using the numbers of the sequence 2, 6, 10, 14, 18, and goes on. Calculate the sum. This is very important again. Remember that other person talked about sum of the numbers of the 8th row. Can we start by finding out what is happening in each row? So row 1, what are we seeing? So this is row 1, right? So row 1, we have got just a 2, right? But in row 2, we have 6 and 10. What can we say about 6 and 10? If we were to add them, they'll give us what? 16, right? So I'm going to write it here. They'll give me 16 if I were to add them. 16. So can you add again row 3 for me so that we can deduce the pattern? Row 3. If we add row 3, it will give us 54. So are we seeing anything in terms of row 1, row 2, row 3? So from row 1, we have a 2. If we look at row 1, to get to row 2, to get the sum, we are looking at what? Okay, let's do 26, 30, 34, 38. Row 4, what is the sum? So that we can look at this. What is the sum? 128. Okay. So do we have a pattern? Yes. Can you see that? To get to row 2, we took row 2 and we multiplied it by 8. Right? So row 1 was 2 times 1, I'll say that. Then row 3, we took again 2 and we multiplied by what? Divided by 54, 27. Right? Row 4, right? 2, 128 divided by 2. What does that give me? 64. Right, there we go. Right. Now, can you see if I multiply each row by 2 like that, I'll end up with 2 times 1, 2 times 8, 2 times 27, 2 times 64. Now, if you look at 1, 8, 27, 64, do we have anything that we can say about them? Do we see a pattern? They are cubes, yes. So it's 1 cube, 2 cube, 3 cube, 4 cube. Right, good. Now, can we now find the sum? So we know that this is the sum. What we have are the sum. Okay, it's the sum, meaning we have added the rows. We have added the rows. We are not dealing with each one individually, we are adding them. So what is the sum of the 8th row? So if row 1, row 2, row 3, row 4 goes like that, can you give me the nth row? What would be the formula for the nth row? It will be equal to, look at our pattern. What would be the nth row? The general term, right? Yes, n is being cubed, but what else is happening? It's not only n being cubed. N is being cubed and what? No one hasn't given me the answer, you know. I'm not looking at the answer, I want the general term. Don't write the answer, give me the general term. N is being cubed, yes. And then what? We are seeing n being cubed here, but there's something else being done to n cubed. What is that? Times 2, yes. So the general formula is what? 2n cubed. So you need to be able to identify that first, guys, before you rush into answer. Now can we do the sum? So row 8. Can we do row 8 now? We now know 2, right? See, remember, row 1, it was what? 1 cubed. Row 2, 2 cubed. Row 3, 3 cubed. So row 8 will be 2 times 8 cubed. And what is our answer? That will be the sum. 1024. Right. Thank you, guys. Do you understand what I've done? I did not just rush into getting the answer because you need to understand what is happening in the sequence. After understanding what is happening in the sequence, then you need to deduce your general formula. Then after deducing your general formula, then you can work out what the examiner is asking you. So first of all, understand what is happening. Okay, why did I not look at 2, 6, 10 and say, oh, I can see 4, 4, 4. Can you see? We're adding 4 each time. I did not deal with them as numbers. Why? Because the question talked about sum. So because the question talked about sum, that's why I went on to add the rows and look at how the rows are related. Am I making sense, guys? So first of all, look at what you are given before you can start rushing to answer. So the idea was I am looking at my sum and then I am checking, oh, they are talking in terms of rows, meaning I need to, they did not ask us for the next term. So that's why I did not use it as a term. I use it as a row, okay? The sum of each row. Now, the next question says, how many of you know what mean is? Mean. What does mean mean? It says find the mean of the numbers of the 20th row. What is mean? Average. Okay, good. So if it is average, right? Perfect. Thank you, guys. Average. So if we want the 20th row, can we not start by finding it? The sum of the 20th row. Can we find it? Right? What is the sum of the 20th row? If we take the 20th row and find its sum, what would that be according to our general statement? So R20, right? Give me R20 to 20 cubed. Right. Thank you, Natalia. Natalia says it's 16,000. Now we want its mean, right? So we said mean means our average. So which means we are looking at the sum of the rows, isn't it? Over the number that we have, the number, the term, which is basically what? What is the term here? 20 rows. So we are looking at our sum, which is 16,000 divided by what? 20. So can you see, if you have not done the general formula for the first one, then you are going to be stuck here again. Right. So what we have? 16,000 divided by 20 will give us the average or the mean. What is our answer? Thank you, Faith. So the mean is 800. Do we understand what we are doing? Guys, ask me questions if you're not sure. Ask me questions. Questions. Be good. Okay. Right. Natalia says she's not sure. All right. Tell me exactly where you are missing it so that I can quickly read it. Is it this one or the first one? The second step. All right. So the idea is the examiner says the mean of the numbers in the 20th row. So obviously the mean means sum, isn't it? Sum of the numbers in the 20th row. So the sum of the numbers in the 20th row, we now know how to do the sum of the row. So the 20th row, we know that if we add all the numbers, according to the formula that we got here, is our 2n cubed. We realize that if we add all them, 20th row, we just substitute where n is, we put 20 and we get our sum. But because it's row number 20, right? So which means there are 20 rows. So what this means is that it's the sum of the rows from R1, R2, until the 20th row, isn't it? So there are 20 rows. So average means that the mean means the average, meaning we are dividing with the number of things that we have, which is 20 rows, over the sum of those 20 rows. So in a way, you could have started by finding each row and add them throughout until you reach the 20th row. But because you already have a formula for that, that's why I just substituted into the formula to get the sum and then divide with the number of rows that we have to find the mean for each row, basically, the average. Is it clear? Okay. All right. Okay. The next question. The next question says, given the linear pattern, 2x plus 1, 3x plus 3, 4x plus 5. The key word here is linear. When I hear linear, what does a linear pattern mean? When I hear the word linear, what comes to your mind? Constant difference. That's why they gave us that linear. So meaning 2x plus 1, 3x plus 3, right? 4x plus 5. Those are our terms. Now they're asking us, we know it's linear, meaning there's a constant difference. They are saying, what is the next step? Can we check what is happening here? Let's divide. Let's subtract. 3x plus 3 minus 2x plus 1 will give us this one. Then 4x plus 5, right? Minus 3x plus 3, right? Can you see that? Okay, what is our constant difference here? Subtract this for me. 3x minus 2x, x plus 2, right? Thank you. X plus 2. So obviously to get to the next person, what must we do? We are adding x plus 2. So let's go 4x plus 5 plus x plus 2. What does that give us? Right, thank you. 5x plus 7. The other way you could have looked at it was to check what we have. You can see 2x, 3x, 4x. Automatically it meant the next number was going to be 5x, isn't it? Then you could also see 1, 3, 5. Meaning 1, 3, 5. You were adding a 2 each time here, a 2 each time here. So if you added a 2 there, then the next number was going to be that 2. So you could have used it that way, or you could have used it that way. Right. Now, right in terms of x, there, general term. So let's go. We now know who our d is, right? D is what? 2x plus 2. So what is our general term? Tn, dn plus c. Right. So let's go backwards. Who is c? Remember, we are putting x plus 2 here. We are subtracting. Right. So c will be equal to 2x plus 1 minus x plus 2. What does that give us? Right. X. 2x minus x, x, 1 minus 2, negative 1, x minus 1. So let's put it in. So what is our general formula? D is x plus 2, right? And we are going to put n there, right? And our c is plus x minus 1. Do we understand? You can expand it if you want. If you want to expand it, you can distribute the n. It will be nx plus 2n plus x minus 1. So in terms of x, that is our general formula. Or you can leave it like that as well. It's okay. Do we get it, guys? So it's a matter of just following as if you are dealing with your numbers. The only difference is that we are dealing with x, not the number. But we are doing the same process. So I still need my d. I still need to find my c as well in the same manner. So remember, c is what? T1 minus d. So you still need to follow that process. That's why I did what I did there. T1 minus d. And because you're dealing with negatives, please put brackets, because the minus sign must affect everyone inside of the bracket. It must affect the whole d, not just x. Right. Okay, then it goes on to say, if the value of the 13th term is 95, calculate the value of x. So what are we doing? We are coming onto our formula, right? We are saying 13, which means n is equal to what in this case? 13, isn't it? So which means T13 is equal to 95. So we are going into the formula and we are saying wherever we see Tn, we are replacing with 95. Okay, then when we see n, we are replacing with 13, right? Plus 2 times 13 plus x minus 1. Can we solve for x now? Right? So this will be 13x plus 26 plus x minus 1, 95. Let's group like this. So it will be 95 minus 26 plus 1 is equal to 13 plus 1, which is 14x. Right? What is 95 minus 26 plus 1? 95 minus 26 plus 1, 70. Right? What is 70 divided by 14? 70 divided by 14. Right? Thank you. So therefore, x is equal to 5. Do we understand it? Okay, so therefore, x is equal to 5. Right, so we've answered that part. Then the question now says, if x was a 5, find the largest value for which Tn is less than 158. So Tn is less than 158, but x is a 5. So who is Tn? There, right? So wherever Tn is, we are going to put it here, right? And we are putting a 5 now where x is, because we know who x is. And we are saying 158, like that. So we are going to end up with 5n plus 2n, 5 minus 1, plus 4 less than 158. What do we call this? Inequalities. I know you did them. Inequality. So 5 plus 2, 7n. Carry the other one across, 158 minus 4, right? So we are going to end up with 7n less than 154, right? So divided by 7, divided by 7. Remember, we only change the sign if we are what? Dividing with the negative. So what is our answer here? N is less than, thank you, Emma, 22, right? Are we done? Not really. The question said, right? Find the largest value of n. So if n is less than 22, what will be the biggest value then? It is smaller than 22. So what is the biggest value? Right, thank you, Emma. N is equal to 21. That would be the largest value. Do we understand? Not 21.9. Remember, n can never be a decimal. N is an element of a natural number, meaning n must always be a whole number. Okay, so it can't be a decimal. You take the first whole number before the 22. That will be n. Right. So guys, in number pattern, n is an element of natural numbers. And natural numbers are 1, 2, 3, 4, 5. Okay, so it can never be a fraction, it can never be a decimal either. It's only a whole number. So whenever they ask you for terms, they are dealing with whole numbers basically. Are we okay? Right. Okay. You need to practice these before your exams, right? Let's go. An air traffic control tower is constructed, right, at an airport. The front view of the lower is shown in the diagram below, right? And AB, the first horizontal support from the bottom, is 7.9 meters long and is secured, all right? To the ground. Additional horizontal supports are secured parallel to AB and are 50 centimeters apart. Each additional support above is 10 centimeters shorter than the one below it. CD is the 45 horizontal support. AD and BC are lateral supports on which horizontal supports are secured. Right, a lot of information, right? A lot of information, right? Let's hear this information. So what is the example talking about? We have got lines that are parallel to each other. But as we go on, we are noticing that each support is 10 centimeters shorter as we go up, right? So the question is, calculate the height h, this h of the tower. What do you think is happening to h? If CD is the 45 support, horizontal support, and we know 50 centimeters, isn't it? So 50 centimeters apart, A and B, all right? They, or the additional horizontal supports are secured parallel to AB and are 50 centimeters apart. So which means this is 50 centimeters apart. But as we go up, each additional support above is now 10 centimeters shorter than the one below it. Now we are looking at the height h. So what do you think we will calculate h like? This height. We have 50, 50, 50, and DC is the 45th one. So what does that mean? If this was the first, right? How many steps are in between until the 45th one? How many? These little things here, 44, thank you. So which means h will be equal to what? 50 centimeters times what? 44, right? Because there are 44 little steps, each CD is the 45th one, because we are also counting this one as our first. So 45 minus 1, which means in between them, there are 44 little things. Can I have the answer? Thank you, Natalia, 2,200. Okay, right. So these are centimeters, because this is in centimeters, right? Now the next question says, now calculate the length in meters of the 45th horizontal one. So we now want to find DC. For us to do that, what do we need, guys? We need a general formula. Who is D? Let's go to the passage. Find D for me. Who do you think D is? Right, 10. Thank you, Emma. Centimeters. But because they want it in meters, can we change the centimeters to become meters? What would that become? 10 centimeters to meters? 0.1. But remember, we are saying shorter each time. So is D positive or negative? Because we are going shorter each time. So it's a minus. Because if the above number is smaller than the bottom one, if I were going to subtract T2 minus T1, it would be a negative. So basically our D is equal to minus 0.1. Right. Now we want to find C. So your general formula is Tn, remember, Dn plus C. And your D here is minus 0.1 N. I don't know who C is. Right. But there's something that we know. We were given one term. Which term are we given? Which term did the examiner give us? Look at the diagram. Which term are we given? If this is the 45th one, the first term is given, and our first term is what? 7.9. Thank you, Emma and Natalia. So we know T1 is equal to 7.9 meters. So let's put it in to find C. So where Tn is, we'll put T1, which means 7.9 is equal to minus 0.1 times 1 plus C. Can somebody give me what C is? Give me C quickly, guys. Use your calculator, take that one across and add them together. C is equal to 7.9 plus 0.1. 8. Thank you. Right. So the general term is Tn is equal to minus 0,1n plus 8. Now we can answer the question. The 45 support. So we want T45. So you can't answer it without that. So how long will be the 45 support, which is CD? T45 will be equal to minus 0,1 times 45 plus 8. Use your calculators, guys. Right. Thank you. 3.5 meters. Okay. Right. This is a word problem. Okay. Right. Word problem. So please make sure that you go over questions like this as well. So sometimes the examiner can be a little bit nasty and give you a word problem. Now the question now says, calculate the area in square meters enclosed by AB, BC, CD, and AD. Let's go. So what do we see? AB, BC, CD. What type of a shape is this? Which quadrilateral is this? We are starting longer here. We are parallel to each other, and we guess. And you can even say trapezium. So if I have a trapezium, how do I find my area? Area of a trapezium? Who remembers? How do you find area of a trapezium? Half sum of what? Sum of the parallel lines, isn't it? Times the height. So your parallel lines here are what? Are DC plus AB times your height H. Right. Do we have all these things? Yes. So do we know who DC is? Yes, we found it just now. Do we know who AB is? 7.9. Do we know who DC is? It was the 45 term, which is what? 3,5. Do we know who H is? Yes, it was 2,200 centimeters. Can we change this to meters? What is 2,200 centimeters to meters? So H is equal to 2 meters. And then we can do the answer, 22 meters. Now you come into your formula, you go half sum of parallel lines, so 7.9 plus the 3,5 times 22. Right, that's the area of the trapezium. What does that give us? 125.4 square meters. Right. I know that science English sent you these questions. Please go over the question again and try to understand it, okay? Go over the question again, try and understand what it is all about. Question 3.5, we've already done it. It's a repetition. Can you see? We've done this one already. So it's a repetition. We've already done it, I think, in question 3.2 or 3.3. I can't remember. They're exactly the same. Right. So please make sure that you go over this question again. I know it's a very interesting question, can be very confusing. So sometimes the examiner can give you things like this in number patterns. That's why I say do not take number patterns for granted. Don't take number patterns for granted.